Hi all, I am Ashwati Krishna, Assistant Professor, Department of EEE, Vedavyasa Institute of Technology. As a part of Tech Talk series, I am here to give a brief idea about reactive power compensation. These are the contents. Reactive power is an essential tool to transmit the active power through the AC network. It is required to maintain voltage of power transmission network for the smooth transmission of active power. In an AC transmission, when the current and voltage go up and down at the same time, only real power is transmitted. When there is time shift between the voltage and current, both active and reactive power are transmitted. The portion of power averaged over a complete AC waveform is the real power. The portion of the power flow that is temporarily stored in the form of magnetic or electric fields due to inductive and capacitive network elements and then returned to sources known as reactive power. It can also be defined as the agent of energy required for the establishment of the magnetic field inside the system. It is very essential in electromechanical energy conversion process. That is Q is equal to Vi sin theta. This reactive power generated or consumed must be within the limit Q minimum less than Q maximum. If Q is greater than Q maximum, the excessive reactive power will set up the flux to be more with core, thereby eddy current increases, which causes excessive heating of core, by which thermal breakdown of insulation is possible. If Q less than Q max, the insufficient magnetic path is created inside the machine, which may cause improper work done, thereby output is not proportional to the input, which leads to problem of instability. Then let's see what's the need of reactive power. In resistive loads, the current produces the heat energy which produces the desired output, but in case of inductive loads, the current creates the magnetic field which further produces the desired work. Therefore, reactive power is the non-working power caused by the magnetic current and sustained magnetism in the device. Then the reactive power is required to maintain the voltage to deliver active power in watts through transmission lines. When there is not enough reactive power, the voltage sags down and it is not possible to deliver the required power to load the lines. Then what is reactive power compensation? Reactive power generated by the AC power source is stored in a capacitor or a reactor during a quarter of a cycle, and in a capacitor or a reactor during a quarter of a cycle, and in the next quarter of the cycle it is sent back to the power source. So to avoid the circulation between the load and the source, it needs to be compensated. To regulate the power factor of the system and to maintain the voltage stability, we need to compensate reactive power. Voltage regulation, stability, proper utilization of machines connected to the system, overcome the losses associated with the system, preventing the system from the voltage sag and voltage collapse. Then what is the principle of power transmission? In an electrical power network, when the voltage is transmitted through the HVAC system, then certain parameters plays a key role. In AC system, actual power is enabled by virtue of imaginary power. To understand the basic phenomenon behind the power transmission, let us model a transmission line, one which contains an equivalent electrical circuit like a 2 voltage source separated to each other by means of an inductance, which is usually transmission line reactance. We can see in this figure. Then what is active and reactive power of the system is given by PR and QR. Power flow can be controlled by applying one of the following means. First one, shunt voltage at the midpoint. Second, varying the line reactance. And third, voltage with a variable magnitude in series with a line. Then what are the types of compensations? Compensation in electrical power system is an essential tool for the improvement of the performance of HVAC transmission line. For the smooth transmission of electrical power, we need to balance the voltage violation limit. To achieve this objective, We can either inject current to control the voltage or inject the voltage to control the current. However, the two basic types of compensation techniques have been used are first one shunt compensation, second one series compensation. Then what is shunt compensation? The device that is connected in parallel with the transmission line is called shunt compensator. It is also known as load compensation. Shunt compensation is used two kinds of technique to improve the system performance in terms of voltage regulation and reactive power compensation. They are shunt reactors and shunt connected capacitors. The figure shows the shunt compensation technique. The next, series compensation. Series compensation is basically a powerful tool to improve the performance of HV lines. It consists of capacitors connected in series with a line at suitable locations. A capacitor in series with a line gives control over the effective reactance between the line ends. It is also known as line compensation. Then what is voltage profile? For the fixed level of power transmission, voltage profile is relatively flat corresponding to the natural loading or surge impedance loading. The reactive power requirements increases with line length. The line is said to be naturally loaded if its loading is equal to surge impedance loading. At surge impedance loading, the reactive power observed is exactly equal to the reactive power generation. Then let's move to FACS technology. In 1980s, Electrical Power Research Institute introduced the concepts of FACS technology, which intensively increased the use of power semiconductor devices for the compensation of reactive power. FACS devices are used to optimize existing transmission lines. And the FACS technology is not a single high power controller, but rather a collection of controllers which can be applied individually or in coordination. Then what are the types of FACS devices? FACS controllers can be classified as shunt connected controllers, series connected controllers, combined series controllers and combined shunt series controllers. And these FACS controllers can be classified as variable impedance type and voltage source converter. Then what is static var compensator or SVC? It belongs to family of FACS devices where the variable impedance is found by controlling the firing angle of power semiconductor devices used. The SVC is designed to bring the system closer to unity power factor. Then what are the types of static var compensation? Thyristor switched capacitor TSC, thyristor controlled capacitor TCR, thyristor switched capacitor, thyristor controlled reactor, fixed capacitor thyristor controlled reactor FCTCR and thyristor controlled series compensator TCSC. An SVC is an automated impedance matching device designed to bring the system closer to unity power factor. If the power system's reactive load is capacitive, then leading, the SVC uses reactors usually in the form of TCR to consume VAR from the system to lowering the system voltage. Under inductive load, that means lagging conditions, the capacitor banks are automatically switched in, thus providing a higher system voltage. Then what is STATCOM? STATCOM is also known as Advanced Static Var Compensators, which is essentially a voltage source converter. Advanced version of SVC with voltage source converter is basically known as STATCOM or static compensator. That can be divided into following categories: STATCOM, shunt connected, then static synchronous series compensator, that is series connected, interline power flow controller, that is IPFC, then unified power flow controller, that is UPFC. Then basically the STATCOM system is comprised of power converters, set of coupling reactors or a step-up transformers and a controller. We can see in this circuit diagram. Advantages of STATCOM: better reactive power support during faults, fast dynamic response, and then ability to generate more reactive power. Both inductive and capacitive region of operation is possible, lower generation of harmonics. Then let me conclude this reactive power compensation. From all the basic discussion, we can conclude reactive power compensation is a must for improving the performance of an AC system. By reactive power compensation, power factor can be improved, reduce the consumption of electricity and increase the system efficiency and it helps to maintain transmission voltage within the limit and then reduce system losses and reduces kVA demand. Okay, hope all of you got a few idea about reactive power compensation. Thank you.